Hello and welcome back. My name is Ryan Hallway and I'm a solutions architect at Tetra Science. Today I'm excited to demonstrate how we can use the scientific data cloud to analyze and visualize batch release and stability data. In the previous demo, we showed how sample data from an ELN is automatically sent to instruments like LabX and Tiamo for analysis. And once the analysis is complete, the results are then automatically sent back to the ELN, all through Tetra Science's scientific data cloud, where the data is stored. Now that the data is stored in the scientific data cloud, we'll show how customers are leveraging Tetra Science's well-engineered data, or Tetra data, for analysis and visualization. In this Streamlit application, we're monitoring batch release and stability for a product by analyzing Tiamo titration data, specifically the water content over time. This application is querying Tetra Science directly to pull near real-time data from the platform. Over the course of 15 months, we can see the absolute measurement of water content slowly increasing, which may be affecting how stable our product is over time. Let's walk through how Tetra Science is unlocking scientific data to be easily consumed in these kinds of applications. With Tiamo, as well as many instrument softwares, a results file is generated. As soon as the file is generated, it's automatically sent to the platform and re-engineered to Tetra data. Tetra data is a JSON-based representation of the data that also exposes the data to be queried via API and SQL. Tetra data is consistent, well-engineered data used as the foundation for analytics, visualization, and AI and ML. Let's have a look at Tetra data for Tiamo titration on the platform. So I'll go up to the platform, and here on the platform, we can query Tetra data directly via SQL. Here on the left, we can see the SQL tables generated as Tetra data for Tiamo. In the SQL query editor, we can define and run a basic query against the Tetra data, where we can get the absolute water measurement in micrograms, the water percentage of a sample, as well as some additional parameters. Now, let's demonstrate how data is ingested to the platform, engineered to Tetra data, and leveraged for analysis and visualization. Looking back at our Streamlit application, we have 32 files processed over 15 months. Let's assume we're now in month 18 and have ran additional samples for titration we'd like added to this chart. I'm going to jump to my remote desktop where I have 4 more titration results from my month 18 run. I'm going to drag and drop these 4 results into a folder Tetra Science is monitoring. In a production scenario, these results files are exported directly to a folder Tetra Science is monitoring, so there's no need for drag and drop. But for demo purposes today, I wanted to show that step. Back to my slides, as soon as those raw Tiamo files are sent to the platform, a pipeline will trigger on the platform to engineer the raw data to Tetra data. And once the Tetra data is generated, my visualization will automatically be updated simply by refreshing the page. We'll go back to the Streamlit application, refresh the page, and just like that, we see the number of files processed jump from 32 to 36, as well as our visualization updated with month 18 results, without having to do any additional data manipulation. As always, the most important thing is driving value for our customers. Customers are spending less time data wrangling since Tetra Science provides clean, structured data. They have easy programmatic access to the data, like via SQL and API, And this is all freeing up scientists' time to do more science and less data wrangling. Thank you for tuning in. And if you'd like to learn more, please visit tetrascience.com.